lesson. Kaya kahit sabihin mong kaunti lang ang iyong alam, tiyak na gagaling ka. Nagbibigay kami ng mga take-home examinations, weekly examinations upang masigurong may naidagdag sa iyong kaalaman. Mentoring program upang sagutan ang iyong mga katanungan patungkol sa lesson. Meron din kaming weekly free webinar with free e-certificate at idagdag mo pa dito ang mahigit na 300 na mga original downloadable videos via our official YouTube channel. Inaanyayahan kita na umattend sa aming special webinar on how does an electrician become an electrical engineer in just 1 year through CHED EPIA program this coming Monday, 6 p.m. to 10 p.m. For more details, send us a message at Marina's Powerhouse FB account or Messenger account. Kung gusto mo tutukan, mag-powerhouse ka na!
East in June, trade the brightest greens of summer for the dreams of navy blue. East in June, leave the calm Pacific breeze for an Atlantic rendezvous. 'Cause I've been driving for days.
Overwhelming po kasi to be honest, sa 8 years po ng Powerhouse, ngayon lang po nagkaroon ng ganitong event eh. First time lang. Because kasabay po nitong event na to, yung pag-launch po ng dalawang bagay po ang ilo-launch namin ngayon. Una po yung PAME, P-A-M-E-E. We call this as Powerhouse Association of Master Electrician and Electrical Engineers. Tapos po yung Power Link, no? Link that makes you bigger. The intention of this is to help contractors and suppliers para ma-promote po sila sa Powerhouse.
Nagtapos na ang 30 kababayan natin na nabiyayaan ng libreng short training course ng Aksyon ni Kuya. Nagbabalik po si Mon Hocson.
Nagtapos na ang first batch ng mga kababayan nating sumailalim sa free training course na ipinagkaloob ng Aksyon ni Kuya Daniel Short Training Courses Program. Sila ang mga nag-aral ng kursong Building Electrician at Wiring Installation. Nagkakahalaga ng mahigit 6,000 piso ang kursong ito, ngunit libre itong ipinagkaloob sa pamamagitan ng Sophia Review Training and Consultancy. Ito ay bahagi ng public service ni Kuya Daniel na makapagbigay ng libreng edukasyon sa ating mga kababayan. Bukod sa libreng training, tutulungan din ng Sophia ang mga nagtapos na makakuha ng lisensya.
Matutulungan din po namin sila in terms of getting their license, PRC license po. Sa field po ng electrician po, ang highest license po na ma-achieve po nila, ito po tinatawag na Registered Master Electrician.
Ang mga lisensyang ito ay maaaring magamit ng mga nagsipagtapos upang makapag-apply ng trabaho sa labas ng bansa o di kaya'y sa mga malalaking cruise ship.
Sa barko po, usually po ito po yung requirement. So maganda po ang opportunity rito pag may license sila. Ang mga full-fledged po na master electrician sa barko, ang sweldo po niyan ranging from 5,000 to 6,000 US dollar a month.
Ito si Lolo Arsenio, 66 na taong gulang. Sa kanyang katandaan, nais niyang samantalahin ang pagkakataon na matuto upang kahit papaano ay magkaroon ng pagkakakitaan.
Kung may pagkakataon na makapagtrabaho, magtatrabaho pa po.
Sa mga darating na buwan ay muling magbibigay ang Sophia ng libreng training sa ating mga kababayan. Mon Hocson, UNTV News Worldwide.
We are one in IIE mission and vision, instilling excellence in electrical profession. Having a dynamic professional association, making me innovate collective contribution to our nation. Our members were stronger than chain and bolt, rising to any challenge involving walls, bombs and bolts. BREENRME, connecting industries by the electric circuits. Join us together, IIB. Join us forever, IIB. With power cords cannot be broken. Join us together, IIB. Join us together, IIB. Join us forever, IIB. Synchronize our hearts to reach greater heights and brighter lives. We serve humanity with the power of electricity, making rigid transmission great for reliability, ensuring little power loss and high efficiency. But shifting from one place, the use of all energy. Join us together, IIB. Join us forever, IIB. With power cords cannot be broken. Join us together, IIB. Join us together, IIB. Join us forever, IIB. Synchronize our hearts to reach greater heights and brighter lives. There's only one institute, no one else can substitute. There's only one
Our speaker mentor for today is a graduate of Bachelor of Science in Electrical Engineering, batch 1996 at University of the East, Caloocan. He earned units in Master of Science in Electrical Engineering, major in Power Systems at University of the Philippines, Diliman, and Master in Construction Management at University of the East, Manila. Former cadet engineer, in-phase industrial construct, former project engineer, Security Bank Corporation, former electrical consultant, Brown Bauhaus Architecture Studio, former training consultant, Meralco, former training director, PAMAV Training Institute, former CPE lecturer, IIEE, WESM, PAMAVTech, former electrical engineering regular faculty member, UE Caloocan, also former electrical engineering faculty member reviewer, Mapua Institute of Technology, Pamantasan ng Lungsod ng Maynila, Adamson University, Rizal Technological University, Technological Institute of the Philippines, Manila and Quezon City Campus, Perpetual University, Las Piñas and Molino, Cavite, Technological University of the Philippines, Taguig Campus, and Pamantasan ng Lungsod ng Valenzuela. He is a registered electrical engineer and a registered master plumber. Ladies and gentlemen, the president of Marinay's Powerhouse Team Review Center, let us all welcome Engineer Reginaldo Kuya Reg Marinay.
Hello, sound check. So magandang hapon po sa inyong lahat. Good afternoon, everyone. Welcome to Marinay's Powerhouse Team Review and Training Center. We welcome you for today's free webinar. Okay, may we request to our participants, Zoom participants, to please rename your Zoom name by only one word, or your nickname only, or any decent code name, please. So, please do not put your full name. Huwag pong full name ang ilagay po ninyo. Diyan po. One word lang po. Even 2 letters will do. Let's say JR, RJ. Pwede na po yon. Sige po. Paki-rename na po. And meron na po kaming sinend, no? So, we have initial registration for this free webinar. So take a look at our Zoom chat board. So nandiyan na rin po yung ating initial registration form. Please fill up our initial registration form in the Zoom chat board, please. Okay, so before we start our live discussion on Industrial Motor Control Part 2, so we will have first our Part 1. Our discussion, so that the newcomer will understand fully our topic for today. So this is an English version of our topic on industrial motor control. Okay, so we can now start. So please open your camera. Please, by the way, please open your camera. Pakibuksan na po yung mga camera natin. We required open camera. So you are only allowed for 15 minutes of cam. Matagal na po sa 15 minutes, more than 15 minutes, you will be removed in the class. This is a policy of our center. So please fill up now our registration form. Pakipila pa na po. And we welcome everybody, those who are watching in the YouTube and in the Facebook Live. Good afternoon, everyone. Okay, we may now start our lecture on Industrial Motor Control Part 1. Then after this, we go directly to Part 2, our live discussion. Okay, so we may now start. Okay, magandang hapon po sa inyong lahat. Muli, kami po Discussion with motor control. What do we mean by motor control? In motor control, it is a broad term that means anything from a single switch to a complex system with components such as relays, timers, switches, and other control devices. So meaning if we have a single switch, even just, let's say it is only an on-off push button, it is already considered a part of the motor control system. An on-off push button will turn to start and stop the motor. So it is already part of the motor control system and it can be part of the complex system. And if we have relays, timers, or magnetic contactors, timing relays, switches, and other control devices. It is the portion of electrical system which starts to stop, changes the speed. Change the speed meaning we can increase or decrease the speed of the motor. Let's say for the case of some conveyor system, elevator system. So if we have a motor control system, we can increase or decrease the speed of the motor. Reverses, like an elevator, it can go up, it can go down, and regulates meaning to control and also to prevent other problem in the motor operation. It regulates motors that drive various pieces of equipment. Here are the functions of motor control. So it controls, regulates the operation of the electric motor. So when you see an electric motor, automatic we have to control and regulate the operation. Any motor must have a control system, especially the large motor system. And we say, let's say if we have 5 horsepower and up, of course, even though it is just a simple motor, we should have a motor control system. It helps protect the equipment and personnel from damage and contribute to efficient and safe operation. So the motor control protects not only the equipment, but also the operator, the personnel, and this will contribute efficiency on the system and of course the safety of the operation. That is the purpose and function of the motor control. Here are some important symbols in motor control. They have the single pole switch. They have the double pole. As you see, it is double pole. Single pole, this is the single pole, only one pole. So in here we have 2 poles. That's why it is called double pole. And then we have the 3 pole. This is for 3-phase system. For the 3-phase system. 3-pole switch. Then we have the double pole circuit breaker. So we have 1, 2, say line 1, line 2. Then we have the 3-pole circuit breaker. It's part of our motor control system. This is for 3-phase system. Let's say phase A, phase B, phase C. Then we have here our fuse. We have the symbol here for fuse. For this symbol, this is a more popular symbol for the fuse. Then we have the overload relay or the overload heater element. I think this is the more popular symbol for the overload relay. This signifies the heater element, what is inside of the relay. Then let's discuss magnetic contactors. Magnetic contactor is an electrically operated switch rated in amperes. The horsepower rating are also available for most contactors. Magnetic contactor basically is also a type of relay. It is a big relay. It is electrically operated. Usually, the rating is in horsepower. It is used to interrupt heavy loads. Relays are magnetic contactors in smaller sizes. So they term it relay. Let's say some electronic in an electronic circuit, you will see some relay, a small contacts, a small relay, just simply being called as a relay, and then a larger relay is what we call the magnetic contactor. Generally rated at 15 amperes, these relays, or less, and are mainly used in control circuits. So these relays allows low voltage pilot devices to control a higher voltage circuit. And remember, there is a question, can you have a low voltage control circuit? Can you have, let's say, if you have a 230 or 460 volt system, can you have around a 24 volts or 12 volts control circuit for your motor control system? The answer is yes. It can. It's possible by the use of the transformer. So wherein you are going to step down the voltage, and you will have some of your motor control devices in the lower voltage. Also your relays. These are the sample pictures of the magnetic contactor. Actually, this free webinar is intended for a newcomer in the field of industrial motor control or industrial electricity. Actually, this is just a bit of information that we'll be sharing with you. This is actually one of our special webinar. And if you want a deeper understanding on this topic, you may avail our special webinar. So this is just a glimpse or just a taste of the special webinar in industrial motor control. Actually, we are conducting special webinar in industrial electricity. So we are conducting this to some companies and also to students and schools or universities. So if you are interested, so you may contact us if you're interested. So this is just a bit of information regarding motor control or industrial electricity. So we call this training program as industrial electricity, wherein we are discussing many portions of industrial motor control on that topic. And also we are discussing some standard. In our country, we have the Philippine Electrical Code and how to size properly our circuit breaker, our relays. That is included in our training or special webinar on industrial motor control. Okay, so this is a magnetic contactor. As you see here, this is our magnetic contactor, and this is our overload relay. You see this one. So our magnetic contactor is simply a switch. This is just a switch. Electrically operated switch. This overload relay is a protection. It is a type of a motor protection that will protect against overload condition. So, well, overload, the difference of overload and short circuit. Overload is, let's say your motor is 100 amperes. Then when you check the the feeder line, the current flowing the feeder line is already, let's say 120 amperes. Let's have this one whiteboard. Let's say we have a three-phase motor. Then this is our line 1, line 2, and line 3. Then let's say we have a clamp ammeter here. So we want to check our current here. Let's say we have here our current. So if the current flowing here is 120 ampere, while our full load ampere or the nameplate current of this motor is around 100 ampere, your motor is basically overloaded. That is overloaded. If we mean short circuit, the difference is, let's say line 2 and line 3, they were accidentally connected to each other. So this would have a short circuit current, a large amount of current that would flow to the fault. This is what we call the fault point. There will be a fault current here. This is not 100, this is not 120, no. No. It can be times 10, it can be times 20, it can be times 30 of the full load ampere. Try to imagine that is times 10. That would be around 100, 1000 ampere, the full flow. Okay? So, or it can be more than that. It depends on the impedances involved in the circuits. Okay, so our protection against short circuit is basically a circuit breaker or a fuse. And then this is the magnetic contactor. This is a single line diagram. And this is the overload relay. So our circuit breaker and our fuse is intended for as a short circuit protection against short circuit. Our overload relay is our circuit breaker or fuse. Our overload relay is basically intended for overcurrent or overload current. Well, short circuit, shall we say short circuit current or what we call the overcurrent. What do we mean by overcurrent in the motor? Overcurrent. Basically, if we mean overcurrent, we mean that is a short circuit current. Short circuit current or what we call the fault current. Fault current. And then we have the overload current. Overload current. Okay. Basically, there are two types of overcurrent. That is why circuit breaker and fuses in the Philippine Electrical Code and also in the National Electrical Code of US, they call this as OCPD. What do we mean by OCPD? OCPD. This is what we call the overcurrent protective device. Our standard code fuses and circuit breaker are being called as the OCPD, overcurrent protective device. Although nowadays there are some circuit breaker designed also for overload. The new technologies of circuit breaker. So if we have here the motor, sometimes there is a circuit breaker, then motor na agad. No? You will see a motor here.
there is no overload relay, there is no magnetic contactor. Because basically, especially in the smaller horsepower of this motor, the circuit breaker is also a switch actually. You don't have a push button, the circuit breaker may act also as a switch. Meaning the function of the magnetic conductor, okay, as a switch being override by the circuit breaker, is taken by the circuit breaker. Aside from being a short circuit protection, and also nowadays the technologies of circuit breaker, they already have an overload protection element or a device inside. No? So this circuit breaker has the capability to trip even though there is no short circuit, even though if it is just an overload current, it may trip. Okay, so there we have, this is a magnetic contactor. See here, that is a magnetic contactor. Then we have an overload, there is a relay or control relay here. This is for a smaller capacity or current of the relay. What is the basic operation of a relay or a magnetic contactor? This is the most basic operation. You will see here, this is an electromagnet. This is a simple electromagnet. Can they see that, partner? So you will see here that this is an electromagnet. This represents an iron core, and this is the winding or the coil. So this is an iron core, this is the winding, and this movable element of the relay is what we call the armature. Armature, the moving part of the relay is armature. This particular example, you will see this is open. This is open. Then as we energize this coil, as we energize this, we put this in line 1 and line 2 of the AC supply. The current would flow, let's say, from line 1, okay? So it will flow to this coil. And then this core will become magnetized. Okay? So remember, if we have a current carrying conductor, let's say this is the conductor, it carries a current. It sets up a magnetic field on this direction. This is governed by the Ampere's right-hand rule. If that is air facing, this is going to the right, right? This is going to the right. And you will have a clockwise direction. Let's go here for the principles. Let's say we have here a conductor. We have a conductor here. So this conductor, it carries a current. It carries a current on this direction. Let's represent this, let's say, by a crossbow. This sets up a magnetic field. I'll just show the direction of the magnetic field. You will see that this magnetic field, well, actually, if you are looking at this point, so you will see here, let's say, this conductor, this plus sign would mean the current is away from the observer. We are the observer. And then the direction of the magnetic field is on this direction.
on this direction. Actually, it is a clockwise direction. Okay, that is the basic principle of magnetism. This is a conductor that carries a current. Once this carries a current, it sets up a magnetic field. As you will see here, the amperes, this is what we call the amperes right-hand rule. You will see here this one, and using my hand that is on the clockwise direction. This is, or what we call the corkscrew rule. Paano ba tayo mag-higpit ng screw? By screwdriver. Diba clockwise? Sabihin, papunta, that is going to the, clockwise is going to the right. Right? Going to the right. Okay. This sets up a magnetic field. That basically we don't see it. Of course, this being studied by our scientists. This magnetic field would flow to the core. You will see here, it will flow to the core. This is our core. This will become magnetized, I should say. This core will become magnetized. As this becomes magnetized, the armature will attract back. That will attract. I remember when we were in high school, we had an experiment on magnetism. We tried to have an iron here. There is an iron core here. May bakal tayo dito. And then we put a coil here. We put a coil. One, we put a coil. And then we put a battery here. We put a battery. And then, let's say there is a switch. And remember that we put a switch here. And then there's an iron fillings. Small pieces of iron here. Small pieces of iron. Once we close this switch, of course, this will become energized. The current will flow to the coil. That will flow to the coil. As the current flowing to the coil, these iron fillings will be attracted. This will attract to this pole, this portion of the iron core. Madidikit siya, no? Didikit. But once we turn off the switch, let's say the circuit is open, wala na to, babalik to. Kumbaga, hindi na didikit. This will not be attracted to the iron core if the circuit is open circuited. You will see these iron fillings being attracted while the current is flowing to the coil. Of course, that is a short closed circuit. What about here? This armature part will attract back. If this becomes energized, this armature will be attracted back. So if that is open, that will become closed. Take a look here. Basic operation of a relay. A relay always has a holding coil. It's what we call the holding coil. There is a coil here. And let us put a push button here. This is a push button. Then this is reconnected to the AC supply. Let us represent this as a relay. Let's have this as a magnetic contactor contacts. That represents a relay. Let's say we have here this is a contact of the magnetic contactors. Let's say this is normally closed contact. You see this one? That is normally closed contact. And all these four, 1, 2, 3, 4, are normally open contacts. They are normally open contacts. Normally open. Again, this is what we call the holding coil. This is what we call the holding coil. Holding coil. This is what we call the main contacts. One, these three. is what we call the main contacts. Main contacts. And this is what we call the auxiliary contacts. Auxiliary contacts. What's the difference between these two contacts? The main contact is being used in the motor circuit. Always remember that motor control diagram has two main parts, the motor circuit and the control circuit. So this is what we call the is being used, in the motor circuit. Motor are sometimes being called as the power circuit. Power circuit. And then the auxiliary contact is being used in control circuit. Control circuit. There you are. Keep in mind that this is only one device. That is only one device. Okay, let's have this one. Again, let's go back here. You see, that is only one device. And also, this one. It's like this magnetic contactor. Only one device. Okay. There is standard markings for this. One of the standard markings we have used before is for the holding coil is A1, A2. A1, A2. So this is 1, this is 2, this is 3, 4, 5, 6. 1 terminal marking. I remember this is 11, 12, and this is 13 and 14 contacts. It can be 21, 22, 23, 24. I saw that that kind of magnetic contactor. It's a larger magnetic contactor. So, what is the basic operation? This is one of the most important idea in the motor control operation. You should understand this principle, the operation of the relay. This is one of the fundamental know-how that we should know in interpreting motor control circuit. Take a look here. This is the main contact. This is the auxiliary contact. As we apply, this is an AC source. As we apply current to the holding coil, let's say this is just a push button. Have you seen a push button? A push button is, there are push button when you push. Okay? So pag pinindot mo, dun lang siya close. When you push it down, the circuit is closed. Then, so you have to hold that. There is a circuit on-off push button like that. You have your finger on the push button. Okay, you press that one, the circuit is closed. Once you remove your finger, the circuit will become open. So you should have your finger here. Okay, you put your finger here. You stay your finger on the contacts or on the push button, so that this will become closed, and the current will flow, let's say from line 1, energizing your holding coil. You will see this holding coil becomes energized. But always remember the term. This term, we will be using this term energized, and de-energized. What do we mean by that? De-energized. It simply means that means energized, of course, there's a current flowing. The energized, there's no current flowing in the circuit. As simple as that. Once we energize this holding coil, this becomes energized. The 1, 2, 3, 4, 5, 6 simultaneously will become closed.
Sabay-sabay ha, I mean simultaneous. No? Simultaneous operation of this contact. You see, for example, I will have my hand here. So this is 1, 2, okay, kita ba? 1, 2, this is 3, 4, and this is 5 and 6. 5 and 6, this one. You see 5, this is 6, right? Okay. So, what is this? This is the normally closed. This is 11 and 12. You see this one, 11 and 12. And then, what is this? What is this? This is 13. Ito, yung nililiit ito, 13. Ito, ano to? 14. Which is normally open. 1, 2, 3, 4, 5, 6 are normally open. You see, this is open. And this is closed. That is 11 and 12. And this is 13 and 14. And this is normally open. Once you energize this circuit, all the normally open, you will see inside the magnetic contactor, this will happen. You see this one? This one. So, ayan, medyo mapagalan lang natin. Take it slowly but surely. If the holding coil becomes energized, you will see this action. See? What happened to all the normally open? Back, it becomes closed, right? But what happened to the normally closed contact? It becomes open, right? That is the heart of the operation of a magnetic contactor. That is one of the most important idea in interpreting motor control system. Even in troubleshooting. When you go to industry, small ones, larger ones, the same principle. Larger ones just becomes more complex system. But if you know the fundamentals, the basic concepts, it would be easier for you to make some troubleshooting when you go to some industrial plant and even in the watercraft or in the ship. You become an electrotechnical officer. You'll be in charge to so many motor control systems in the watercraft or in the ship. Okay? Sa mga barko. Because the watercraft is a large industrial plant. It is an industrial plant, basically. Watercraft that's considered to be industrial. Electrically speaking, that is industrial. That's why in the watercraft, in this watercraft, even let's say you just had a something in English, yacht lang, still it is a watercraft. If you have a boat, if you have, of course, a large ship. No? I remember what's that they call the large ship? Titanic. The Titanic. They call this as the unsinkable ship. The Titanic. I saw that partner in the YouTube. No? The Titanic, the unsinkable ship that is being said by the one who made the Titanic, the one who engineered, the engineer who made the Titanic. He said this. And I was found myself nangilabot. Ano ba English ang nangilabot? I was what's that feeling? I think that's a ridiculous feeling. You see, there is the engineer who made the Titanic. He said this because I watched a documentary on the Titanic. I just clicked it in the YouTube. He said that even God will not sink this ship. You see, even God will not sink this ship. How stupid that word is. See, but what happened to Titanic? It fell down. It submerged itself in the bodies of water. So it's really hard to say. It's really hard to judge. Better not to judge. My brother, because he is not a cover, it's like Melanie Professor. Okay. So, ito tayo napunta doon. Okay, so, because in watercraft is an industrial craft. So many watercraft. There is no watercraft that has no motor control system. That's impossible. That's impossible.
All building has motor control system. All building, 100%. You go to your house, even just a residential building, there is a motor control system considered to. Once you have an air conditioning system to your house, you have a motor control system. Inside the air conditioning, there is a control system there, a motor control system. Sa bahay lang nga, may motor control system na. No? Lalo na pumunta ka ng mga commercial building. Again, once you energize this holding coil, what happens? This will become packed, that will become closed, and the normally closed will become open. Did you get that? Will you thumbs up? Okay, tingnan nga natin. Mga ka-aware pa, thumbs up na kayo. Okay guys, will you thumbs up if you get if you're getting our discussion on motor control? It is a very, very important principle that you have to know. That principle of the magnetic contactor. Let's see. Okay. Okay, I hope you understood the basic operation of the magnetic contactor or relay. Let's go over here. It's another picture explaining the operation of the relay. Again, take a look here. You will see here that this is a normally open contact. You will see this is normally open contact. You see there is an armature. You know, basically, if we mean an armature for the magnetic contactor, even in the machineries, right? If we mean armature, it is a moving part. It's a moving part. One. Take a look here. This is the electromagnet or the coil. If we mean an electromagnet, an iron core plus the winding or the coil is equal to electromagnet. Remember that. An iron core plus the winding is equal to electromagnet. So, once we energize this to the voltage source, the AC source, the current will flow here from line 1, energizing your electromagnet. Once this becomes energized, of course, this will become magnetized. Once this becomes energized, this will become magnetized. The armature will be attracted, and the normally open will become closed, right? What about here? You will see here a normally closed contact for the relay. Once you energize this coil, the armature will be attracted, and the normally closed will become open. Are you getting me? Guys, are you getting me? Please thumbs up. This discussion is intended for, if you would ask me, I would want my student to be a zero knowledge in this topic. Well, if you have already a knowledge in motor control, that's good for you. But our basis for our discussion, I base my discussion on the zero knowledge students. Let's say you just have a little knowledge on electricity. Just know a little knowledge about direct current circuits, alternating current circuits, and that would be enough. Okay? And a bit of magnetism, that would be enough. Anyway, we are being discussed these basic principles. You will see here, the normally open becomes closed, the normally closed becomes open. It's a very important idea. Now, we have here, okay, magnetic contactor, auxiliary contact. This is the holding coil of the magnetic contactor. We discussed this before. So we have here an overload contact. The overload contact is the contact of the overload relay. This is the contact of the overload relay. This is the overload contact. Normally closed or NC, normally open or NO contact. magnetic contactor, main contact. Okay? So, usually the magnetic contactor is attached with the overload relay. You will see here that the overload relay also has a contact. An overload relay has a heater element. It has a heater element and a contact. What is the function of this contact? The heater element is connected to the motor circuit, to the motor or power circuit. The overload contact is basically connected to the control circuit. Always remember that the motor control circuit has two parts or two components, the motor circuit and the control circuit. Remember that. If you will take a look at the overload relay, an overload relay, let's say a three-phase overload relay. Let's say this is the heater element. This is the heater element of the overload relay. That is being connected to the three-phase motor. Let's say this is the three-phase motor. This one. And then you will see a contact here. This is only one device. This is only one device. That is only one device. The heater element, you have your tester, okay, your multi-tester. You're going to connect your multi-tester here. It is connected. Here. On the upstream and downstream. This one. That is normally closed. This heater element are normally closed. This element, normally. Of course, this is normally closed. This is normally open. When overload occurs, what will happen? What will happen when overload occurs? This normally closed will become open. Bubukas yan. That will become open. Let us represent this as an open heater element. That will become open. If there is an overload condition, this normally closed will become open. And this normally open will become closed. This is during overload. If there's an overload condition, see, the heater element becomes open. The normally closed contact becomes open. The normally open contact will become closed. All at the same time. Simultaneous, sabay-sabay yan. Hindi po pwede yung hindi po pwede yung pag nagkaroon ng overload. Uy, overload. Bubukas ako. I will open first. Line 1, pop. Line 2. Next is line 2, pop. Next is line 3, pop. There's no operation like that. Why? Why there's no operation like that? Even though the overcurrent is just on line 1 or phase A, let's say phase A, phase B, phase C. Even though the overcurrent is just on this phase, on phase A, this should also be open. That should also be open. Isn't it said that only phase A is overloaded? So we should only be the one to open. No, that's wrong. That is not the case For the case of the overload relay, no. It should not be happening. Why? If the overcurrent is only on the phase A, and then this ether element is the only element that will open, and this is still closed and closed, what will happen? That is dangerous. You will burn your motor. Why, sir? Why? Because you are supplying a single phase source. This will become single phase only now, right? That will become a single phase. That is a single phase. But your motor is a three-phase motor. Large amount of current would flow to B and C. And this will become overloaded. That will heat up, that may burn the windings. That's dangerous on the part of our motor, on the Decatrion. That is why if there is an overload, all the three must open simultaneously, but all the three contacts. And then this normally closed will become open. This is on the part of the control circuit, and this is on the part of the motor circuit. Anyway, we will discuss this next meeting on the part 2 of our free webinar. Okay? I hope you understood the basic operation of the overload relay. Okay? So we already discussed the two. We discussed multi-contactor and overload relay operation. And of course, we discussed fuses, circuit breakers. Let's take a look here. Let's go now to the timing relay naman. No? Timing relay. Let's take a look at the timing relay. What are timers or timing relay? These are relays that introduce time delay in its operation and use also in sequence control operation. Contacts are available with on delay or off delay. Contacts are also available for time to open, and then there is time to close. Okay. I will discuss first the basic operation of timing relay. Although we will continue this next meeting because this is quite more complicated with, compared to the overload relay and magnetic contactor. A timer is also a relay. That's why it is being called as timing relay. Let's take a look at the basic operation. This is the basic principle. This is the basic principle. It also has a coil. This is the coil. Okay, let us put a push button also, just like in the magnetic contactor. This is an AC source. And then, this is normally open and normally closed contact. I will discuss this basic idea, although I will continue this next meeting. Once you press this push button, this will become closed. The current will flow here, energizing your holding coil. I remember the standard terminal is 27 of the timing relay. Once you energize this coil, this holding coil, that coil of the timing relay, it depends on your setting. Let's say you have 3 seconds. No? You have 3 second setting. You have 3 second setting on your timing relay. 3 second setting. Once you energize, stop. The current will flow here. Once this becomes energized, that will start counting. Okay. Once this becomes energized, 1, 2, 3. This will become closed, and this will become open. The normally open becomes closed. The normally closed becomes open. When you reach the 3 seconds, it will not right away close and open this contact. No, there is a delay. You see, that is one of the basic operation of the timing relay. You introduce delay on the operation. Okay? So yun muna siguro. I think that would be it for today. We have no more time. It's already 5 p.m. We will continue. We will stop here. We'll stop here. We will have more lecture next meeting on motor control. That will be the last part, the part 2, and we will have it, maybe we can have around a 2 hours lecture, a longer lecture, live lecture next meeting on industrial motor control. We are I think this is just around 20 or 30% of what I want to teach in this free webinar. So I want to see you again next meeting. Okay? We will stop here first on the timing limit. Okay? So, with this, I should say thank you. Salamat po. Ikaw ba ay electrician o technician na matagal nang nagtatrabaho, ngunit hanggang ngayon, minimum salary, more or less pa rin ang sweldo mo, pag minamalas ka pa, ikaw ay makukuryente, masusugatan, at mapipilayan pa. Yung electrician ang posisyon mo, ngunit maraming dagdag na trabaho ang binibigay sa iyo na wala namang kinalaman sa pagiging electrician mo. At hanggang ngayon, yan pa rin ang buhay mo kahit ilang taon ka na sa kumpanya. Paano na ang pamilya mo? Ito ang isa sa mga solusyon sa problema mo. Sabi nga ni Dr. Jose Rizal, edukasyon ang solusyon sa kahirapan. Maaari kang makakuha ng diploma o college degree at maging isang licensed electrical engineer sa loob lamang ng 1 taon. Ito ay sa pamamagitan ng Executive Order No. 330 ni dating Pangulong Fidel V. Ramos na kanyang nilagdaan noong May 10, 1996. Ito ang Expanded Tertiary Education, Equivalency, and Accreditation Program o ang ETIAP na maging bahagi ng educational system ng ating bansa. At ang Commission on Higher Education ang magpapatupad nito. Makakatulong mo naman ang MPHT Review Center sa iyong pagre-review upang maipasa mo ang board examinations. Hi! Ako nga pala si Engineer Reginaldo Kuya Reg Marinay ng Marinay's Powerhouse Team Review Center o MPHT. Kami ay nag-o-offer ng mura ngunit high-quality review programs. Nakapag-produce na ng 1,000 registered master electrician, registered electrical engineer, at registered master plumber sa loob ng 12 years. Swak na swak sa mga old graduates ang spoon-feeding style sa pagtuturo sa MPHT Review Center. Ibig sabihin nito ay tinatrato namin ng mga bata o yung kaunti pa lang ang alam ang aming mga estudyante upang maituro namin ng detalyado at step by step ang bawat lesson. Kaya kahit sabihin mong kaunti lang ang iyong alam, tiyak na gagaling ka. Nagbibigay kami ng mga take-home examinations, weekly examinations upang masigurong may naidagdag sa iyong kaalaman. Mentoring program upang sagutan ang iyong mga katanungan patungkol sa lesson. Meron din kaming weekly free webinar with free e-certificate at idagdag mo pa dito ang mahigit na 300 na mga original downloadable videos via our official YouTube channel. Inaanyayahan kita na umattend sa aming special webinar on how does an electrician become an electrical engineer in just 1 year through CHED ETIAP program this coming Monday, 6 p.m. to 10 p.m. For more details, send us a message at Marinay's Powerhouse FB account or Messenger account. Kung gusto mo tutukan, mag-powerhouse ka na!
Okay, good afternoon, everyone. Welcome to Marinais Powerhouse Team Review and Training Center. We welcome everyone to our free webinar. Okay, so do you hear me, guys? So rinig po ba ako, mga ka-aware pa? Thumbs up naman dyan kung rinig po tayo. Magandang araw. Tayo po live ngayong araw ng December 11. No? Yeah, so we welcome everybody. Okay, klaro po yung ating audio and video. Klaro po ba? Is that clear? Okay, so our Zoom participants, no? So when we finish our discussion, please do not leave yet. We still have our final registration for you to get your PE certificate. No? So that you can get that later. No? We're going to email your PE certificate. Okay. Okay, let us continue our discussion about industrial motor control. This is actually part 2 of our lecture, industrial motor control. Okay, so we have the topic, no, the timers. Okay, so what are timers? Or these are actually timing relays. Timers or timing relays relays that introduce time delay in its operation and use also in sequence control operation. The contacts are available with on delay or off delay. The contacts are also available for time to open or time to close. Okay, so we have the figure for timing relay. Okay, and then a timing relay, just like a magnetic contactor, it has a holding coil. It has a coil in it. Okay, so you will see the coil here for this particular relay. So the relay usually is numbered 2 and 7. So this is the coil of the relay. We are going to energize this. Okay, so these are the contacts. We have 1, 4, 3. Okay, so 1, 4 is normally closed. Normally closed contact, and this is normally open contact. And we have 8, 5, 6. 8, 5 is normally closed. 8 and 6 is normally open. Okay, so we have here the time delay relay. This is the holding coil of the timing relay. Then we have the time to close, timing relay contact. There is time to close. This is time to open. This is the normally open push button. You see the symbol. And this is the normally closed push button. Then we have the brake make push button. It has 4 terminals here. Okay, make brake push button. I will discuss what is the difference between on delay and off delay relay. So many students are asking me, what is the difference between on delay and off delay? Okay, so let's go to the board. So let us discuss first the on delay here. Left side, then we have the off delay. I will discuss first the on delay operation. So we have here the holding coil of the relay. That's the holding coil. Okay, for example, we have a push button here. So this, when we see this one, makikita ba nila? Okay, I hope you're seeing our simple diagram. This is the basic difference of the on delay and off delay timing relay. Okay, so this is the holding coil of the timing relay, and I will use first our normally open contact. Normally open contact. So our push button, I've experienced using a push button. There is a push button when you press your finger on it. No? You push it down. Okay, the circuit will become closed. This, you are going to press this push button. This will become closed. Okay. That will become closed. And current will flow from line 1 going to line 2 of the circuit. So this holding coil will become energized. So that will become energized. Okay. This holding coil becomes energized because we press this push button. Okay. There is a push button that it is closed until after you depress. Meaning, this will be continuously closed as long as your finger is continuously pressing on it. Yung nakababad siya, no? In our language, in Filipino. So, kung nakababad ito, no? Okay, if your finger will stay there, pushing it down, this will be continuously energized. When you depress, you remove your finger, it will go back to the original position. So our holding coil will be de-energized. From time to time, we'll be using the word energized and de-energized. Simply, if we mean energized means there is a current flowing. Okay? So, let's say the switch is on. The circuit is on. If we mean de-energized simply means the circuit is off. Or let's say the relay, the timing relay is off. Meaning there is no current flowing in the holding coil. If we mean energized, there is a current flowing to the holding coil. That's the difference between the two. Okay. There is a push button. When you press that push button, your finger is still on that push button, pressing it down. That is closed. Of course, this is continuously energized. When you depress, this will become open. That will become de-energized. Then also, I've experienced a push button. Once you press only one time, you press it one time, pop, that will become closed. When you press again, pop, that will become open. That's another type of push button. Okay? So, let us assume first that this is the first type of push button I have discussed. What I mean is your finger will stay there at the bottom of the push button. Let's say when you press this one down, pressing it, that will become closed. The current will flow from line 1 going to line 2. As we energize this timing relay, if that is on delay, for example, we have 3 seconds setting, 3 seconds. 3 seconds setting. As we energize this one, the relay will start counting. Okay? Once we press this, pop, this becomes energized. The holding coil will say it to himself, I was energized.
I will count 3. Let us pre-assume first that I am the holding coil. Okay? Oh, I was energized. I will count 3. 1, 2, 3. Once you reach 3 seconds, this will become closed. That will happen for the on delay. Meaning the delay is on. There is a delay. It will not act right away. It will not act right away. No. It is opposite with the magnetic contactor. The magnetic contactor, once you energize this holding coil, right away, there is no delay. That will become closed. Once this becomes energized, there is no delay. In on delay, meaning the delay is on. There is a delay. Once you energize this, this will become energized. Once this becomes energized, for example, I am the holding coil, I was energized. I will count 1, 2, 3, this will become closed automatically. That will become closed. Okay? That will become closed. 1, 2, 3, that will become closed. As long as your finger is continuously pressing this push button or you're holding this one, pressing it downward, this one. But once you release your finger here in the push button, this will become open and this will become de-energized of course. That will become de-energized. Once this becomes de-energized, this will go back to its original position. Okay? So that will be the state of the on delay. I don't know if you are getting me. Nakuha po ba mga ka-Werpa? Did you get that? Will you raise your hand if you got my discussion? Because in Powerhouse, this is the way we teach. We'll teach some portion, and of course, we will ask our students if they are getting it. And then we can repeat it over and over again. Well, of course, depends on the time. Okay, we still have the luxury of time. We can repeat it over and over again for you to understand. Okay, but it's just a simple operation. Again, once you press this push button, that will become energized because the current will flow from line 1 to line 2, energizing your holding coil. Once this becomes energized, this will start counting. 3-second setting. Remember, 3-second setting. 1, 2, 3. That will become closed. Okay, just like in basketball, you know. 1, 2, 3. You're still in the paint. 3 seconds. Did you get that? You're still on the paint, right? Inside of the paint of from the 15-foot line. You see? Like in the basketball game. So, 3 seconds. Anong tawag nyo sa atin sa Pilipinas? Nangitlog, no? Nangitlog. Yeah? Nangitlog siya doon. This is the on delay. Let us go now with the off delay operation. What is now off delay? This is the basic operation of the off delay. This is the holding coil of the off delay relay. Okay. Again, this is the holding coil. You see the coil there. And we have here the normally open push button. Normally open contact, sorry. This is normally open, of course. See? You have your line 1, line 2. Okay, take a look. The off delay relay, no? If we have here a push button, pressing it down, the current will flow from line 1 going to the coil, energizing your coil, then returning to the line 2, to the source. So this becomes energized. That becomes energized. In the on delay, this will not close right away. But in the off delay, once this becomes energized, this will act right away. That will become closed right away. Just like in the magnetic contactor. See? Just like in the magnetic contactor. That is the initial action of the off delay relay. But where is the 3 seconds, Kuya Reg? No? Where is the 3 second setting there? Okay. Again, once you press this push button, pop, the current will flow from line 1, energizing your holding coil, going to line 2. This will be closed right away. Pop. See? That becomes closed right away. Instantaneously, I should say. We mean instantaneously. Right away. There's no delay. But why is it called as off delay? Why it is called as off delay? Remember, what happened when this becomes energized, this becomes closed. I have a 3 second setting. Now, I will de-energize this. Of course, again. I will press this. My fingers still on the button. Pop. Okay. My fingers stays there. Okay. Of course, that is closed. The contact is closed. Current will flow from line 1, energizing your holding coil, going to line 2. And this right away will become closed. Now, if I'm going to de-energize this coil, okay, I will depress this one. Depress. Press, depress. Okay? But do not be depressed. Okay? Okay. So please listen carefully. Do not be depressed. Okay. I will press this. I just mean depress is when you release your finger. That is already depressed position. Right? So, if I am going to depress this one, that will become open. The circuit becomes open. Okay? De-energizing your holding coil. This becomes de-energized. As this becomes de-energized, it will start counting 3 seconds. Remember, once this becomes de-energized, before it de-energizes, that is closed. Once this becomes de-energized, this is still closed until you reach 3 seconds. Okay. Once, again. When you press this, the current will flow here, energizing your holding coil. This will become closed. Okay. When you depress this one, this holding coil back, the energizing your holding coil, that will start counting. 1, 2, 3. Back, that will become open. That is the basic difference. I don't know if you're getting me. I hope so. We are trying our best. Okay. I will make it in our language so for the benefit of our Filipino students. I will speak Tagalog. Okay? Okay. So, pag pinindot natin to, I will press this. No? Pag pindot ko dito, dadalo yung kuryente, may energize yung holding coil. This will become holding coil. That will become energized. And this contact, mag-close kagad yan. Walang delay doon. Eh bakit tinawag na off delay, Kuya Reg? Pag pinitawan ko to, doon pa lang siya magbibilang. Binitawan mo, yung pagbitaw mo rito, sasabihin ng holding coil. Sabi ko kanina, ako yung holding coil. No? Uy, nag-energize ako Magbibilang ako. 1, 2, 3. Pak, doon pa lang siya bubukas. Now, are you getting me? Thumbs up naman siya. Kung naiintindihan ko ako, maka-aware pa. Okay? I hope so. You are getting me. Okay? So, this is a critical operation of the timing delay. It's very important. No? If you have a timing delay, okay, it's very important. You know the operation of these different types of delays. Now, let us continue. We have the push button, we have the start stop. Start stop means on off push button, just the same. Okay. The motor, we have a water pump at home. Okay, we have a limit switch here. We have the normally closed, normally open limit switches. We have resistor, solenoid. Here, resistor, solenoid. Solenoid is, it looks like a resistor also, but usually in the circuit diagram, it is in both. It is thicker. It has a thicker line. See, this is a solenoid, and only two stripes. It's like a sine wave, right? So 1, 2. And then in the resistor, you can have it only 1. You can have it 2 stripes, 3, 4. Okay. So, but in solenoid, you have your 1 stripe, no? Let's say positive, then you have negative. Something like that. So, it's like just remember the sine wave, right? So we have the pilot indicating light. Okay. Okay. Let me discuss to you a limit switch. What is the basic operation of the limit switch? I remember we had a project in the university before when I was teaching in the university. We have a champion project. There is an exhibit conducted by one organization, a school organization, the students organization, engineering. So we have a champion project. I remember the champion project. Me and my student did that project. It is a simple operation of a cable car. Alam niyo ba yung cable car? Diba? Uso yun sa Japan, saka sa Korea, diba? Sabi nga ni Robin Padilla, diba, solution daw yan, isa sa solution sa traffic. No? Gusto niya magkaroon ng cable car sa Pilipinas. Our Senator Robin Padilla wants to have a cable car. The basic operation is a forward-reverse motor control. But what is hard in the cable car is that, okay, forward-reverse just like this one. But the problem is your cable car will go up and then we go, let's say, to the left, okay, then going downward, and then going upward, then going to the right, going downward, something like that. It just looks very simple, but it's very hard to do. That's why that project becomes a champion. We put some mountains, some trees. There are some cars. There are some small figures of small human figures. No? Okay, miniature. I mean miniature. Just like what architecture students are doing. They have a miniature of the scale model, I should say. It's like a scale model. And there is a cable car. You see? We use a limit switch. I remember that one. We use a limit switch. We have a limit switch for forward reverse, and then for upward and downward, we have a limit switch. What's the basic operation of the limit switch? This is a limit switch. Inside the limit switch is there is something like a diagram, almost the same as a three-way switch. Say a single pole, double throw, something like that. A representation of the three-way switch. There is also in the limit switch. Okay, there are connection. This is what is inside of the limit switch. This is like a wheel, gulong. May gulong siya. So, this one. In the elevator, in the crane, there is a limit switch. So there is an external connection here. There is some metal here. Okay, there is a metal. This is, let's say, the common terminal. And then there is an external connection here. This one. And then there is an external connection. One. there is a spring here, somewhere here. There is a spring. So, if we're going to have our multi-tester or signal ohmmeter here, from this point up to this point. Okay? Your meter will deflect to 0 because this is a short circuit, right? Papalo, hindi. Papalo. Of course, if you have a tester, okay, let's say this is your analog multi-tester or ohmmeter. 0, this is infinite, right? So this is now your pointer. If your pointer go to 0, meaning the 0 resistance, the 0 ohm would mean shorted. Shorted. There is a continuity, right? It's like this one. That is a shorted. If your pointer will not deflect, initially our pointer is in the infinite position, meaning the resistance is infinite, meaning this is open circuit. This is open circuit. Okay? So we have this one. Okay. Of course, this will deflect. That will deflect to 0. Because that is shorted, right? And then, once it touches a certain object, this will, gulong to, wheel. This is a wheel. Small wheel of the, just like this one. Take a look here. Pakita natin yung gulong. Let's see. There is a small wheel in the limit switch. You see? There you are. See? There is a small wheel here. And then the 3 contacts are this one. 1, 2, 3. Okay, this is 1, 2, 3. 1, 2, 3. Okay, let's go here. Once this is in contact with another object, this wheel, there is a spring here. This is movable actually. That is a very soft metal. This one is a very soft metal. Once a certain object touches this one, just like an elevator, that will be in this position. What will happen is this will be in this position, just like this one. Say this will be its final position. Once this goes down, this contact will become open. And this will become closed. That's the difference. See? Pag tinamaan ito, mag-o-open to, mag-o-close to. Okay? When this wheel is in contact with another object or another body, this will go down, this will become open, and this will become closed. Of course, if this becomes open circuit already, this will go back to original position, which is, that is open. Again, that should be infinite resistance. That will be infinite resistance. That's the difference. That is a limit switch. Then of course, it will go to the original position. Okay? This will go back to original position here. This will become closed. Okay? That is a limit switch. Okay, we have the motor overload protection. This is an overload relay. Okay. Actually, I already gave you an idea about the overload relay. The purpose is to protect the motor windings from excessive heat due to motor overloading. When you overload a motor, this is normally closed, actually. This is going to the motor circuit. That is normally closed. If the motor becomes overloaded, let's say your motor is 100 ampere, but once the current flowing is more than 100 ampere, this will become open. Okay, simultaneously, the 3 contacts here will become open simultaneously, sabay-sabay. But once this becomes open, the normally closed will become open. And if there is normally open, that will become closed. Okay? That is the action of the overload relay. Okay? Or
thermal overload relay. I think I discussed this in the part 1 already. This one. Okay. The 95 and 96 contact are normally closed. 97, 98 are standard normally open contact of the overload relay. Let's take a look. So we have a single phase motor. We have a 3-phase motor here. We have a 3-phase motor. Of course, there are 3 leads, T1, T2, and T3. Okay, let's go to power circuit. Power circuit. Conductors are sized in according to the current drawn by the motor and form the power circuit. This current, this conductor carries a current going to the motor. Going to the motor. Okay, so this is the power circuit. We have the control circuit. It contains the control devices that will initiate the starting or stopping the motor. Let's say you have a switch here. You're going to energize this motor. This holding coil, let's say, that is a control circuit. We'll have more of this. We have the magnetic motor starter. It's an electrically operated switch rated in horsepower and provides overload protection. This is the magnetic motor starter. This also provides overload protection. What is inside the magnetic motor starter? Okay, there is a switch here. You start the motor. We have the schematic diagram. Take a look here. Schematic diagram of magnetic motor starter. You see this one? There is a magnetic contactor. There is overload relay already in the magnetic motor starter. It's actually a combination of contactor and overload relay inside of it. Let's have some wiring exercises, basic exercises. Okay, this is a push button. When you press this one down, of course, this will become energized. Okay, this is normally closed push button. Okay, of course, initially this is closed. This is energized. Once you depress this one, once you press this one, this will become de-energized. That will become off. Okay, we have the single pole, single throw switch here. One. Of course, initially, lamp B is energized. Lamp A is de-energized. But when you press this one, pop, this will become energized and this will become de-energized. We have now two push buttons in series. We have basically two push buttons. Let's have first is two push buttons that is connected in series. Of course, initially this is off position. That is off. The bulb is in off condition. You have to press both so that this will become energized. Right? You want to press both and you close the switch, of course, it's more energized. No? So that will become energized again. So we have a two parallel push button. Basically, a two parallel push button represents like a three-way switch. I want to on the lamp on this position.
No? I want to off the lamp on this position. I can on and off the lamp wherever you go, whether you are here or you are here. Just like this one. Okay? You can on this, pressing it down, this will become energized. When you turn it off, pressing it down, again, this will become energized. Okay, this is the basic operation of a magnetic contactor or relay. This is the heart of the operation of the magnetic contactor. Take a look here. This is the holding coil of the magnetic contactor. Once we press this push button down, pressing it down, the current will flow from line 1, energizing your holding coil C. Once this becomes energized, 1, 2, 3, 4 will become closed, energizing your 2 lamps. Okay? And also at the same time, this auxiliary contact 13 and 14 will become closed. That will become closed. Okay, mga ka-aware pa? So that will become closed. So, as long as you energize this holding coil, continuously energizing this holding coil would mean continuously energizing your 2 lamps here. But once you depress this one, okay, once you release your finger, pump, okay, is there still a current flowing to the bulb? That is my question. Is it still energized, the 2 bulb? Again. I will press this push button down, tap. The current will flow here, energizing your holding coil C. This will become energized simultaneously. Tap. The current will flow here, energizing this now. At the same time, this will become closed. Once you press this one, now, if I'm going to depress this one, tap, of course, this will become open. Question. Would that mean if this becomes open, this is already the energized? The answer is no. The answer is no. Why? Because once we press this push button back, energizing your holding coil C, this will become closed. Once this becomes closed, you depress this push button back. Once this becomes closed, the current still flowing here. This becomes closed. The current is flowing here, energizing your holding coil C. The current is flowing here, energizing holding coil C because this becomes closed. Even though you release your finger here, pop, this is continuously energized. As long as there is current flowing to this holding coil, this will continuously be closed. That is the idea. I hope you're getting me. Thanks, Menji. Thanks, Menji. Yun, naintindihan ako. Okay? So, naintindihan ha? Naintindihan ha? Okay? That is the idea of the magnetic contactor. That is what we call the latching effect. Latching effect of the magnetic contactor. That is the idea. That is the purpose of this 13 and 14. Once you energize this holding coil, you're pressing it down, energizing your holding coil C, this will become closed. As this becomes closed, remember this becomes closed. That is closed. There is current flowing here. Once this becomes still current flowing here,
But still, there is a current flowing here. You release your finger here, this becomes open. There's no effect. There's no effect because the current is continuously flowing to 13 and 14 going to the holding coil C. Okay? So that is the idea. That is the idea. Now, let us go now to the application. We will now go to starting methods. Motor starting methods. Let's have some basic principles. First, full voltage starting. This is the motor. A motor started by connecting motor directly across the line. Or full voltage. No? Full voltage starter is operated either manually or magnetically. We have the manual motor starter. It's the magnetic full voltage starter. There you are. You see, this is what we call the full voltage or the across the line magnetic starter. This one. Take a look first at our figure. Take a look at our figure. As you are seeing this circuit, take a look here on this circuit. Looking at this circuit, we are doing nothing on this circuit. Is there any energized part or portion of this circuit? What is that? Can they see the circuit on the? They see that. Okay. So anyway, looking at this, okay, so let us take a look here. Take a look. This idle lamp is initially energized. You see, we're doing nothing yet. Wala pa tayong ginagawa sa circuit. Because this is line 1, line 2, and line 3. Okay. Take a look here. This is line 1. Okay. This is line 1. Okay. The current flowing here. Going to line 2. This idle lamp, let's say this is color red. If you are the operator in the industrial plant or power plant, even though the motor is a few meters away from the control room or monitoring station, you are aware that that motor is not energized. Meaning idle. This motor is the energized. Idle means, in the dictionary, it means useless. It's not working. Idle. Okay? So, we have here idle. This is energized initially. Now, let us go here with the start button. I will press this push button. Back, I will press this. This is normally open. This becomes closed. The current will flow from line 1. Okay. Energizing your holding coil C and your run lamp, of course, because they are connected in parallel, right? Energizing your holding coil C would mean, this simply means that these 3 contact, 1, 2, 3, 4, 5, 6, all at the same time, simultaneously, will become closed. Sabay-sabay yun. Energizing your motor, right? Your motor will become energized. At the same time, this latching contact, 13 and 14 will become closed. At the same time, this 11 and 12, okay, this will become open, de-energizing your idle lamp. And the one running is the run lamp already. Let's say this is color green. As you see, there is a color green now. The red one turned off, but the green one turns on, meaning you already know, even though that is 100 meters away from you, especially the power plant. The motor are very far from the monitoring station, even hundreds of meters away. So take a look here. Say this is color green. At least you are aware, you know that the motor is running, even though it is 200 meters away from you. Okay? See this one? So, once this becomes energized, this tree will become closed. Okay? Then your motor now is running. It's running condition. Now, what happens if your motor becomes overloaded? If it becomes overloaded, the overload heater element will become open. Pop. If that becomes open, pop, the overload contact here, 9596, will become open. And this will become closed. At the same time, this will become closed. Because your motor becomes overloaded, 97 and 98 becomes closed, the current will flow here, energizing your fault lamp and your buzzer. Once you hear your buzzer, you know, pag tumunog yung buzzer mo, meaning there is a fault. If you heard your buzzer, see, there is a fault on your motor. There is an overload condition with respect to your motor. That is the idea. That is across the line magnetic starter. Usually being used for low voltage, usually 600 volts and below, the across the line on the full voltage. Why is it called as a full voltage magnetic starter? Because this your motor, if you have your 230 volts, you will start your motor right away 230 volts. The voltage is full already right away. Now, let's talk about the primary resistance starter, or shall we say the reduced voltage starter. The reduced voltage starter. We're going to study three types of reduced voltage starter here. No? So, we're going to study primary resistance starter, auto transformer starter, Y delta starter. Okay. So, what is the idea of the primary resistance starter? That is one type of reduced voltage starter. Reduced voltage starter simply means we are reducing the voltage. We are decreasing the voltage, the impressed voltage on your motor. But how it is being done? I will discuss first the basic principle of the reduced voltage starter, the primary resistance starter. Primary resistance starter, the PRS. What is the basic idea of the primary resistance starter? Okay. Okay, so there is a resistance here, resistance unit, and this is our motor. This is the basic idea. Please take a look here. We have here the source voltage. We have the source voltage. We have the load voltage, or simply the motor voltage. Our load here is our motor. There is a certain voltage drop here. The voltage drop is the voltage at the resistor. If we have a voltmeter here, let us tap this voltmeter to these two terminals. There is a certain voltage here in the resistor, because there is a current flowing here. May kuryente dito. There is a current here. Let's take a look here. Let's have the Kirchhoff's voltage law by Kirchhoff's voltage law. Actually, the Kirchhoff's voltage law, he has its son. What is that? What is the name of the son of the Kirchhoff's voltage law? The powerhouse chop law. What do you mean by powerhouse chop law? We are using this in our review center. Okay. So, the voltage here plus the voltage here is equal to the voltage here. Simply, the source voltage is simply equal to the load voltage plus the voltage drop. Again, the voltage here plus voltage here is equal to the voltage here. See? Okay. Ganun lang po kasimple. Huwag na tayong mag-Kirchhoff's voltage law. No? As simple as that. The voltage here at the load plus the voltage here is equal to the voltage here. Okay? So, let's take a look at the voltage at the load or the motor voltage. The motor voltage, take note that it is the load voltage. If we are to get the load voltage, simply let us lipatize this. You know lipatize? Ilipat lang, ilipat. No. Transpose. Okay. So, hindi tayo maintindihan ng mga Amerikano. So, we will go to transpose this voltage drop. So this is our Vs then minus V sub T. See? Simply, if we have a 230 volts, okay, this is an easy manipulation, of course. Assuming disregard first all the angles, no? That is AC circuit. So let us just to see the basic principle. If this is 230 and this is 30 volts, of course, 230 minus 30 volts, the voltage at the load will just be 200 volts, isn't it? As simple as that. Okay? So, the voltage of the motor is reduced, wherein your motor is 230 volts motor. That is a 230 volts motor. Now, what is the application of this resistance? Primary resistance starting. So, we have here a contact. Normally open contact. See? Take a look here. In parallel with the resistor. In parallel with the resistor. Okay. Let's say you have a timing relay for 3 seconds. On delay timing relay for 3 seconds. For 3 seconds. Okay. Once you switch on, okay, the current will flow here for 3 seconds. Then, once you reach 3 seconds, this will become closed. But once you reaching 3 seconds, then the current now will flow here. The resistance becomes a bypass resistor. The bypass na, no? Because there is a bypass conductor here. They call this as bypass conductor. What is the idea of the bypass conductor? Take a look here. If I have a simple series circuit here, this is 1 ohm, 2 ohms, 3 ohms. Okay. Then that is connected to a battery. What is the total resistance of 3 resistors? Simply 1 plus 2 plus 3. Okay, calculator. No need. Okay. It's simply 6 ohms, right? That is 6 ohms. But if I am going to connect a bypass conductor here, see? Initially, of course, if there's a battery here, the current will flow here, right? Without a bypass conductor. But if I'm going to put a bypass conductor, the current will flow here to the 1 ohm resistance. Will it go to the 2 ohm resistance? No. Will not go to the 2 ohm resistance. Always remember the current will flow to the lower resistance portion of the circuit, which has the lower resistance. It's like a water. Water will flow to a lower floor or lower ground, lower surface. That is the idea. Okay? The current will flow here from line 1 going to the bypass conductor here, then the 3 ohms. Okay, that one. That is the basic idea. Now, In the primary resistance starter, once this becomes closed path, all the current here will go here to the normally closed. Actually, this is normally open. This held closed. That held closed. This actually, once you read this, this is what we call the normally open held closed. It was held closed. The current will flow here, then go into the motor. You see, the current will no longer flow to your resistance unit. If you have a 3-second setting, let's say 1, 2, 3, you're going to use this resistance unit for only from 0 to 2.99 seconds. But once it reaches to 3 seconds, automatically this will become closed. That is just a sample setting. That is my sample, the 3 seconds. Let's go to the circuit here. We have the start button. Once we press the start button, pop, the current will flow. Of course, that is connected to line 1 and line 2 here. The current will flow here, energizing your S holding coil. Take a look here. Take a look. Energizing your S holding coil. Once this becomes energized, and take a look first, the S becomes energized, and the timing relay contact, the holding coil here, for the timing relay is energized also. Let's say I just have a 3-second setting. 3-second setting. Once I press this push button, pop, current will flow here, energizing your S, and then your timing relay energized. Okay. Once this becomes energized, S, of course, the S contact 1, 2, 3, 4, 5, 6 simultaneously. This will become energized or instantaneously energized. Once this becomes energized, all at the same time, the current will flow here. Take a look here. The current will flow here, and it will flow to your resistance unit, right? Because this is open circuit, right? It will go to the resistance unit, just like our example before. Initially, 0 to 2.99 seconds, the current will flow to the resistance unit, going to the motor. Also, the same thing here. The current will flow from the source, going to the resistance unit, going to the motor. That's the idea. Now, 0, let us count 3 seconds. 0, 1, 2, 2.1, 2.2, 2.3, may point pa eh, no? 2.4, 2.9, 2.91, 92, okay? 2.99. But once we reach 3 seconds, okay, 3, what will happen? This normally open contact will become closed. Pop, that will become closed. Remember, your S is energized. That is closed also, right? That is a latching contact. The current still, there is a current flowing here. There is a current flowing here. This becomes closed. The current will flow here, energizing your arm. Take a look here. What will happen if we energize our arm? Okay? Ano mangyayari? What will happen? Energizing your arm would mean all the R contact here, the main contact will become closed. All at the same time, not one at a time. Okay? All at the same time, sabay-sabaw. Sabay-sabaw. No? So, sabay-sabay yan. The current will flow just straight from the source going to the motor. Question, if your main contact R becomes short-circuited here, this becomes closed. Is there any current flowing to the resistance unit? No more. Because of our principle before, I discussed with you, the bypass conductor. This acts as a bypass conductor. See? There is a bypass conductor. Okay? Take a look here. That is the basic idea of the primary resistance starter. That is the basic idea. So, there is a resistance unit, let's say you set your timing relay for 3 seconds, you will just use this for around 3 seconds. Okay? To protect your motor. Because your motor may damage once you impress directly all the full voltage. This may damage. Okay? That's why you need to put the resistance units. Let's go with auto transformer starter. Take a look here. Auto transformer is quite similar. The principle of auto transformer is quite similar with the resistance starter. So 3-coil starting transformer with tops at 50%, 65%, and 80%. So we're going to use the transformer top setting. We can reduce the starting current to 300 to 480 times of the motor rated current. Okay, by the way, before we forget, we are conducting actually a lecture. It's either online or a face-to-face lecture. You may invite us, to your school, to your companies. Actually, we are conducting lectures so many years. I think it's more than 10 years. I am conducting lectures about it's not actually 10 years. It's more than 20 years. I've been teaching for 25 years already. I've been teaching for 12 to 25 years. So we are conducting this lecture also not only to the universities and also to different companies. So just this year, there is a cold storage company requested a training, what we call the industrial electricity training. So maybe few of you will become interested. We are conducting tutorials, lectures, to the different schools, universities, and even companies. We are being invited by these companies. So, and if you are interested, just contact us at Marina's Powerhouse messenger account. So this is just actually for me, this is just a glimpse of motor control. This is not the deepest discussion. Although, are you learning something? Thumbs up na, guys. May natututunan naman, kahit libre lang. Oo. Pero mas may matututunan kayo kung may bayad. So, actually, we will conduct. Actually, we already have. We have what we call the self-paced training. We have the self-paced webinar. If you're interested, you can contact us. Later, I will discuss that in our marketing workshop. Let us continue on auto transformer starter. Why is it called as auto transformer? Because there is a transformer here. There is a transformer here. What is the function of this transformer? Basically, the principle is the same as the resistance unit. Take a look here. We are using a certain part. That's why it is called as there is a transformer top setting. We are going to consider a certain portion of the winding of the transformer. The advantage of the auto transformer is that it has a reactance. Before, primary resistance starter only has resistance, pure resistance. Auto transformer starter has inductive reactance, XL. Of course, this is the resistance. The transformer has a reactance. What do you mean, sir? What is the function? Ano ngayon? So, this reactance is another voltage drop. Would mean another voltage drop. You can increase the voltage reduction, I should say. Mas mababa mo pa yung voltahe. You can decrease the voltage more. Desirable. Okay? So, this is the basic idea. There is a voltage drop here. so that the voltage of the motor will become decreased or it will reduce. Once you reduce the voltage, always remember the basic principle of the motor. At starting condition, I'm saying this at starting condition. At starting condition, you have an induction motor, no? The starting current is directly proportional to the starting voltage. Always remember that. That is the basic principle of the motor. I want to reduce the starting current because the starting current, a high starting current, may damage the winding of the motor. I want to reduce the starting current. What shall I do? Of course, you reduce the voltage. Therefore, you reduce the current, the starting current. You reduce the starting voltage would mean reducing the starting current. That's the basic idea. Let's take a look at the circuit. Even the torque, about 25 to 64% of the normal starting torque. Okay, so see, let's go now to the circuit diagram. Okay. Take a look here. It's quite a complicated diagram. No? So okay, so we have here a start button. Take note that there is a timing relay contact here, 1 and 3. It is an instantaneous timing relay. What do we mean by this one? Instantaneous timing relay contacts 1 and 3. Once we energize the timing relay, this will automatically close right away. Okay? So just like in the 13 and 14 of the magnetic contactor. Right? So take a look here. This is the power circuit. And this, or the motor circuit, this is the control circuit. Take a look here. Let us press the start push button. We press the start push button. The current will flow here. Okay. Take a look here, energizing your S contactor. Also energizing your timing relay. Also, take a look. This becomes energized. Also your Y contactor. Your Y contactor simply here, this contactor. Okay. So there are 3 holding coils are being energized. The 2 magnetic contactor coil and the timing relay coil becomes energized initially. Okay. Let's say 3 second setting. 3 second setting. What will happen from 0 second to 2.99 seconds? What will happen? Okay. Remember STR, the timing relay, and the Y contactor is energized. The S is energized, this will become closed. The Y is energized, that will become closed. Where is the current flow? The current flowing is on this direction. Take a look here. This is energized, the S. The current will flow here. Okay. And then you're seeing here a 60% top. We are just using the 60% top. Of course, it depends on your application. Whether it is 50%, 60%, 80% top setting. Depends on you. Okay? On your application, I should say. So, this is the 60% top. The current will flow here. Okay, going to the motor. Another one for line 2. The current will flow here. Okay, and then going to the motor. And then also this one, the current will flow here and then going to the winding. Okay, that one. Okay, that is the flow of current from 0 to 2.99 seconds. Okay, so 0 to 2.99 seconds. Remember that there is a timing relay contact here. There is a number of 85 and 86 of the timing relay. Take a look here. Once this timing relay becomes energized, take a look. Take a look here. Okay, it will start counting. It will start counting. Let's say 0, 1, 2, 2.1, 2.2, 2.3, okay? So, what will happen here is 2.8, 2.9, 2.91, 92, 93, 2.99, ano? Okay. 2.96, 2.97, 2.98, 2.99, 3. Pak, what will happen? This close will become open and this becomes close. Nakita nyo open to, no? This will become closed. Once this becomes closed, this becomes open. Of course, if this becomes open, this is energized. The Y, this Y will become open. The 3Y here. Take a look. The R becomes energized. The R becomes energized. Initially, okay, from 0 to 2.99 seconds, the Y is energized. Okay. This is open. By the way, there is an electrical interlock here. Once this becomes energized, the 11 and 12 is this will become open. This is assuring, no, that this will not be energized. But once you reach 3 seconds, what will happen? But this will become open, this will become closed. The current will flow here. Take a look here. Energizing your magnetic contactor R. This would mean the R 1, 2, 3, 4, 5, 6 will become closed simultaneously. The current will flow here. Take a look. Now, question. Dadaloy pa ba yung kuryente dito sa motor? Dadaloy pa ba yung kuryente sa autotransformer? Will the current still flowing? Will it flow to the transformer? No more. Hindi na siya dadaloy. It will not flow anymore to your motor. Why? Why it will not flow to your transformer, I mean? Why? Because the R here becomes energized because the 11 and 12 of R will become open. That simply means you de-energize the S. If you de-energize the S, 1, 2, 3, 4, 5, 6 will become open, going back to its original position. You energize the R, this will become closed, the current will flow here. I hope you are getting me. Okay? So that is the basic idea of the auto transformer motor control or reduced voltage starter. We will go to the last type of motor starter for today. Actually, in our special training or webinar, we'll discuss more types of motor starter. You know? We'll go to the Y delta starter. This is being given by the our authority here in the Philippines, the TESDA. They're giving this in the NC2 National Certification 3 regarding motor control. The starting current, 200% the motor rated current. Basically, this is the cheapest motor starter that we are going to study today. Then you're reducing the starting torque. So take a look here. I will discuss first, not just like what we did before. I will discuss the basic principle of Y delta starter. Let us recall our three-phase system. Our three-phase system. We have our Y delta. Y first, then it will become delta. It refers to the connection of the winding. The Y delta starter. Take a look here. Let us consider first, we have a Y connection. Okay, so meron tayong Y connection dito. No? Let us consider first the voltage. Let us consider the voltage. This is the line voltage. And this is the phase voltage. or the coil voltage. Remember in Y connection or in Y system, the VL is equal to square root of 3 of B phase, meaning the coil voltage, that is the B phase. In the electrical system, it is being called as the line to ground or line to neutral system. For motor, it is called as the phase voltage. The phase voltage would simply mean line voltage or line to line voltage divided by square root of 3. That is the basic idea. Meaning the voltage being reduced to approximately 58%. What do we mean 58%? For any values of this, consider this is 1 over square root of 3. What is 1 divided by square root of 3? By the way, I don't have a calculator here. That's 1. 1 divided by square root of 3 is 0.577. Or shall we say 57.7%, or simply 0.577. That is our phase voltage. 57.7% of the line voltage. Meaning, you multiply 0.577 times, let's say 230 volts. The line voltage is 230 volts. 132.79 volts. Let's say your motor, let's say from 0 to 2.99 seconds, you have a 3-second setting, no? Okay. So from 0 to 2.99 seconds, the winding of the motor is connected in Y. See? 132.72, approximately the voltage of the coil of this motor. Once you reach 3 seconds, it will become delta. It will become delta. Take a look here. We're going to put our circuit here. So let's say this is A, B, C, or line 1, line 2, line 3. This is our coil. Take a look here. This one. It's actually our coil connected to AB. This is actually coil BC. And then CA. That one. AB, BC, CA. Once you reach 3 seconds, the winding of the motor becomes delta. So therefore, in delta connection, take note of this. In delta, our line voltage is simply equal to the phase voltage. If that is 230 volts, the PL, if that is 230 volts, this will also be equal to 230 volts, the phase voltage, because of the basic principle, the basic idea of delta is the line voltage is equal to the phase voltage. In delta connection, always remember that. Always remember that. Okay? Let's take a look at our circuit. We have a Y delta starter. See? This is the power circuit or the motor circuit. This is the Y contactor. This is the delta contactor. This is the winding of this motor. This is a what shall I call this? A standard motor connection. Next meeting, I will have a live lecture on the 3-phase motor standard connection. I will discuss that next meeting. It's a promise. Live, again, it's a live discussion. We're going to study this 6 leads out, 9 leads out, 12 leads out motor. How are we going to connect this? We are seeing here a 6 leads out motor and Actually, it's not applicable to 9 leads out, the Y delta starter. Why? I will discuss that next week. This is a continuation of motor control training next week. I hope you will attend next week, next meeting for our live free webinar. Take a look here. We have a Y contactor, we have a delta contactor, meaning this contactor will make this winding delta connected. This Y contactor will make this winding Y connected. So therefore, initially, the connection is Y. That's why it is being called as Y delta, because Y, that is the starting condition of the motor. Delta is the running condition. Once you reach 3 seconds onward, let's say. Take a look at the one. Oops. Then the control circuit of the Y delta starter. Again, this is M1 timing relay. This magnetic contactor timing relay. Another magnetic contactor. This is Y magnetic contactor. This is delta magnetic contactor. This is 1112 of Y, by the way. One of Y. I correct this one. Take a look, guys. Take a look. Let us stop first the starting condition, which is from 0 to 2.99 seconds. Doon muna tayo. Let us focus first ourselves from 0 to 2.99 seconds. What is the connection of the circuit? Once we close this circuit, we press this push button, pop, the current will flow from line 1, energizing your M1. Your run lab energized. Your timing relay will also be energized. Okay. Take a look, your M1 becomes energized. Your M here, 1314, will become closed, right? The run lamp will run, of course, no? Okay, the timing relay, okay, we start counting. Once it is being energized, it will start counting. It's 1. Pagbibilang na yan. Okay, from 0 to 2.99 seconds, 3 seconds, of course. That is your setting. What is within the 3 seconds or 0 to 2.99 seconds? What will happen from 0 to 2.99 seconds? What will happen? Okay. Remember that initially, the Y contactor becomes energized. Again, let's take a look again. See? From 0 to 2.99 seconds, the Y contactor, holding coil, no, is being energized. See? That becomes energized. The Y contactor. Once the Y contactor becomes energized, what will happen here? Take a look here, guys. Take a look. Once this becomes energized, the Y contactor here will become closed, right? Sarado lahat yan. This will become closed. If this becomes closed, this simply means it's like shorting all that 4, 5, 6 terminal of the motor. There, isn't it that it is short-circuited? No. There is a winding here. There's a certain resistance or impedance here. Once you short this, it's like this becomes closed. Also the same as saying that this becomes short-circuited. It seems like it is short-circuited, the T4, T5, and T6 of the motor. But it's not. This simply proves, no? Once you close these 3, okay, this simply proves that this coil, 3 coil, are connected in Y. But how is it? Take a look at the white coil. The relay contact 1, 2, 3, 4, 5, 6 is just like this one. This is the line 1, phase A, phase B, phase C. This is the 1, 2. This is the 3, 4. This is the 5-6. You see? Once this, always remember that initially it is open circuited, right? Wala pa yan. Nakalutang pa. These three windings are floating. Nakalutang pa to. But once we close, once we energize the timing relay, this will become closed. Then, of course, the current will flow here from line 1, from coil to the neutral. This is the neutral. From line 2 to the coil to neutral. Line 3, coil to the neutral. Okay. And also the same thing as this one. Take a look here. Line 1, going to the coil to neutral. This 3 represents the neutral because this was held closed, isn't it? Are you getting me? Okay. Oh. So, this is closed. Di ba? Closed na yun eh. So, again, A, going to the coil, going to the neutral. The current will flow. B, going to the coil, going to the neutral. We have your C, it will flow here, then to the coil and going to the neutral. Remember, this circuit has no relation to this circuit because this is open circuited. Take note, this is the delta contactor. Walang kinalaman to doon. This has no relation with the Y circuit here. Are you getting me? Hello? Are you getting me? Okay. That is from 0 to 2.99 seconds. See? Wala 0 yun. Hanggang 2.99 seconds. So, the connection of these three windings is connected in Y. This serves as the neutral of the motor. That is the neutral. Now, what will happen when you reach 3 seconds? Take a look again at our control shift. Remember, this three coil becomes energized, isn't it? Once you press the start button, this 3 becomes energized. The timing relay becomes energized. Oh, I was energized. I will count 3. Okay, 1, 2, 1, 2, 3. Pack. You see? This normally closed will become open, and this normally open will become closed. Energizing your delta contactor. Now the Y contactor is being de-energized. Are you getting me? Can you write on? Nakasakay ba kayo in Tagalog? Okay? Nakasakay kayo doon. Bumukas ito, energize ngayon to. Remember, you energize the delta. Once you energize the delta contactor, once you energize this delta contactor, what will happen? Okay? Remember, you already energized the delta contactor. Okay? Once you energize the delta contactor, this thing would happen. Of course, the Y is energized. This will become open. No? We'll go back to its original position. This 3 will become closed, right? All at the same time. Now, what is the proof that these 3 windings are now connected in delta? It's not anymore Y. What is the proof then? Take a look here for the basic principle. Again, remember that the current will flow here from A, will go to the A of the coil, A, tapos yung coil, and then going to the B. Let's say the flow of current is from A to B. That is why is being called as AP. This coil, BC, the current will flow from B going to C. And then from C, the current will flow here, C, going to A. So that is simply AB, BC, CA. AB, BC, CA, AB, BC, CA, AB, BC, CA. Take note of that. That's how you are going to study, especially for the licensure exam. You have to speak just in your room. Do not speak in public. Makaisipin, nasiraan na ng ulo ko. Are you crazy? So, if you are speaking in public, okay, do not speak in public, just in your closed room. Okay, that's AB, PCCA, that's delta connection. If we have AN, BN, CN, that is Y connection. That's the basic idea. Okay? Okay, for delta, we should have a connection from A to B. AB, BC, CA. What is then the proof that we have AB, BC, and CA? What is the proof? Okay, let us prove that we have AB, BC, and CA. Okay. Going back here to our control circuit, okay. So our delta becomes energized here. Our delta becomes energized. So the Y becomes de-energized. Okay. What is then the proof that this is now connected in delta? Before it is connected in Y. But now, if this becomes closed, all the three are connected in delta. Okay? So let's take a look here. We should create A, B, B, C, C, A, right? The current will flow from A going to B, from B going to C, from C going to A. No? What I mean is, again, take a look here. No? A, so you have your coil. In between A to B, there should be a coil. In between the two lines, there should be a coil. A going to B, of course, you have your coil. B, there is a coil. C. C, there is a coil in between A and C, or CA. Let's take a look here. What is then the proof? So we have, this is A, B, C. So this is our A, okay? Our A here, okay? Take a look, meaning this is closed. This is our A, okay? This is closed, connected here. So there is a coil, okay? So that is A. So by the way, first, we have here, let's go first here, this one. I will consider first this one because your M is closed, okay? By the way, the M is closed, still closed. So the line 1 or the A, the current will flow here from A, going here from A, so the coil, and then let us trace this one, okay? That is closed, okay? That is going to B, you see? Okay, let's make it more lively. There is a current flowing from A. Take a look here. This is A. A, B, C. Remember that. A, B, C. Okay. If that is A, okay? So this is A. Okay? Take a look, ha? Take a look. A, B. You see? This coil is connected to AB, isn't it? AB. Okay. You have your B here. B. See? Did you see that? In between, there is a coil. What about C? This is the C. Tinapos na. Oh, C. A, you see? CA. That simply proves that these three coils are connected in delta. Are you getting me, guys? Are you getting me? And okay. Let me see your thumbs up, guys. Okay. Thank you. Salamat to. Okay, that is the basic idea of why Delta started. Okay, that's one of the most important starting method of a three-phase model. Okay, and we believe that you can use this. This is very useful, especially when you go to the field and even in the skills test. Okay, so or trade skill test, that's very useful. Okay. We can even have, if you will invite us in your school or in your company, we can have some actual connection. Actually, we have equipments on motor control. We can have this one. If you would like to invite us, no, you may do so. You may contact us, no, if you are interested to have an actual. I'll be the one. Ako mismo magtuturo sa inyo. I'll be the one to teach you personally. Okay. Even actually, I am teaching one-on-one or two-on-one. Let's say you are two, there are two students, no? We can conduct a tutorial lecture. No? You may contact us. Okay? See? Okay, so, well, that's the end of our discussion. Thanks be to God, mga kawerpa. Maraming salamat po. And thank you very much. No? We'll see you then. God bless. Okay po mga kawerpa. So pupunta muna tayo sa ating marketing presentation. Sige, partner. Kita natin yung marketing PowerPoint natin. We'll discuss some marketing, no? Iraround lang po namin. Mabilis lang po, no? Kasi meron pa rin po kaming klase. No? We still have a class at 5 p.m. Facebook. Two slide. Facebook. No. Okay mga kawerpa, yung ating okay po mga kawerpa, yung ating pong registration habang nagdi-discuss po ako ng marketing. Pakilagay na natin. Pwede nyo na pong fill upan po yung ating siguro maya-maya na lang. 5 minutes po. Okay, sige, ganito na lang po. Focus po muna tayo. Saglit lang naman po mag-fill up. Okay, so for the first timer, so pakita niyo po. Yes, okay, here's the name of our center, Marina's Powerhouse Team Review and Training Center, or just simply MPHT Review Center. Gusto mo tutukan, mag-powerhouse ka na. Okay, this free webinar is brought to us by UNTV. No, if you think you're getting a quality lecture, no, this is also brought to us by UN Television, your public service channel. They are our major sponsor for this event. No, palakpakan naman natin ng UNTV mga kawerpa, no, or because of them, sila po ang isa sa ating gasolina. Ika nga, no. So, napakalaking tulong, sobra, no, ng UNTV po sa atin dahil may magandang kalooban po sila na tumulong sa ating mga kapwa-tao. No, na-extend po hanggang sa ating maliit na review center, no, na tulungan po tayo ng UN Television. No, salamat po ng marami. Kay Brother Eli Soriano, kay Kuya Daniel Rason, thanks be to God, no, sa kanilang pangunguna na aprubahan ang partnership po way back 2010, no, na tayo ka-partner po ng UN Television, no, your public service channel. No, and lately, last year, no, naging partner na rin natin ng ating national organization, ang IIEE. This is a continuous every Sunday free webinar. No? Right now, we are having it on an English version, a series of English version lecture. No? We started this last November, just last November. So, expect that every Sunday, we will have an English version of our lecture. So, from time to time naman, there is a Tagalog word. Kaya maintindihan nyo pa rin talaga. So, okay, this is a very nice news, very good news to everybody. Okay, so this is just the second week that we are going to announce this one. No, this is an extended announcement. Okay, NPHT Review Center in cooperation with UN Television. Review now, pay never. We offer free 50% up to 100% discount. No? So, first, we're going to give you free review course. Actually, the free review course is already complete something. No? For RNE, Technical PEC, for REE, Math, SSE. So we will extend our help, no? Not only for REE, RME, and also for Master Plumber, and also for licensure exam for teachers. We'll give you free review. Review now, pay never. No? There's no requirement that, shall we say, grade requirement. There's no grade requirement for this. No? You may apply effective for 2023 board examination. The review program for RTE, RNE, Master Plumber, and licensure exam for teachers. You may apply for the scholarship. When is that going to happen? Okay, actually, well, we are already through with the batch 1, 2, and 3. Wala yata dito yung 4 and 5. Hindi pa nailagay. The batch 4 and batch 5. Okay, just write it down. Write it down. We will have it on December 14. The batch 4 will be on December 14. Madali namang tandaan. Batch 4, sige, pakitype mo dyan, partner. So, the batch 4 will be on December 14. The batch 5 will be on December 16. We will accommodate all scholarship applicants. We will discuss all the detail regarding the scholarship program. Okay? So, the batch 4 is on Wednesday, December 14, 6 to 8 p.m. The batch 5 will be on December 16. That will be the last batch. If you are interested, you may apply to our pre-review course. Okay? Wherein you can save, more or less, you can save 10 to 20,000 pesos. That's big amount of money you can save. No? So makakatipid po kayo ng malaki. Okay, for the meeting ID and passcode, just see our FB post for detail. No? We are going to post that tomorrow. The Zoom link or the meeting ID and the passcode. No? Papakita po namin sa inyo. Bukas po, pakisilip nyo lang po yung aming ipopost na FB ads. Okay, this is the name of our YouTube channel, the Reggie Marina YouTube channel. Please subscribe, like, and share to my YouTube channel, mga kawepa. No? So, we have the Reggie Marina YouTube channel. Okay, as of December 11 a.m., no? Our number of subscribers for 2 years of its existence. No? Our YouTube channel already gotten subscribers of 13,800 subscribers, and Your channel has gotten 577,948 views so far. And thank you very much. No? Maraming salamat sa mga nanood, no? Ng mga kawerpa natin dito sa ating YouTube channel at expect that we'll be doing more of this. No? Gagawa pa kami ng maraming pang videos para po sa inyong lahat. No? For free, pwede nyo pong ma-download ito at pakishare na rin po sana mga kawerpa. No? At and if you may, kung po pwede po sana, no, kaunting tulong, malaking tulong po sa amin ito. Kung mapanood po ninyo yung ilang segundo ng mga commercials dun sa bawat video namin, no, so para tuloy-tuloy po kumbaga ang ating mga paggawa, no. So pakipanood niyo na rin po pati yung mga commercials po natin na lumalabas doon sa mga videos, no. So ayan po mga kawerpa, at maraming salamat. Nasa mahigit kalahating milyon na pala tayong views, no? Tumitingin po sa ating YouTube channel, ang Reggie Marina YouTube channel. And I hope na kayo'y maging member ng MPHT Review Center private group. So meron po tayong private group mga kawerpa. So mag-request lang po kayo at i-ano po namin kayo, i-add po namin kayo sa aming private group, MPHT Review Center. Okay, we have an early bird promo or special promo for online review course. Actually, this is not just a review course. This is already with refresher and coaching. This is a complete review program. No? For RTE, we have 14,000 pesos. For RNE, registered master electrician is 11,000. For master plumber, we have 12,000 pesos only. No? So that is our special promo if you're going to avail our review program only up to December 16. Ulitin ko po, hanggang December 16 lang po yan. No? Ito po yung ating regular price. No? Discounted price. No? Tataas na po yan after December 16. So, ito na po yung package price natin. All-in na po yan, mga kawerpa. No? So, baka sakaling magka-interest po kayong mag-avail, no? Ayan po ang ating price. We also have self-paced review program. You can review anytime, anywhere, any number of times. No? Po, pwede po. No? So, andyan dyan po yung ating pong mga program. No? Actually, for April board exam, no? For RE, RME, so you may avail our self-paced. Kahit anong oras, kahit nasan ka, kahit paulit-ulitin mong panoorin yung aming mga review lectures, yung mga original videos namin, maaari mo pong ma-access yan, no? 24/7. No? So, ayan po. We are also selling our webinar. No? We have what we call the webinar series with e-certificate and 3 original videos, no? For only 249 pesos per topic. So there are 33 topics to choose from if you are interested, guys, no? At makakuha kayo ng marami ring mga certificate, magamit nyo sa pag-apply nyo ng trabaho, local, even in abroad, no? Magagamit nyo po itong mga certifications na ito. At yung mga gusto mag-aral ng ETIAP, no? Yung mga electricians natin na gusto mag-aral ng engineering, no? Kailangan marami po kayong mga certificates dyan, no? Ito po yung mga special webinars namin, mga kawerpa. You can take a look at this in our website, no, the Marinay Powerhouse website. Makikita niyo po yung link dyan. Pinopost po namin sa aming FB account. The building wiring installation, industrial motor control. No? So, kung gusto niyo pang mas gumaling pa kayo sa motor control, no, so you may avail. No? Maraming topic pa po. No? Siguro yung naibigay lang po natin sa inyo, wala pa po sa kalahati yan. No? Wala pa po. Baka mga 25% lang yung ating na-discuss. No? Yung 75%, baka gusto po ninyo mga kawerpa mag-avail. No? So this is good. This is only 990 pesos. No? Pag nakita nyo sa website namin, 990 pesos lang po yan. No? Pwede na natin ipa-fill up yung sign up form. Okay, we have industrial motor control, then we have electrical design course. Hinati po natin, maganda po ito, hinati natin sa tatlo, no? Module 1 is residential design, Module 2 commercial industrial, Module 3 is high-rise building design, no? So, ando doon po yung ating detalye, no, sa ating website, ano? Practical electrical estimation course, no? Meron din po tayo niyan, no? Yung mga gustong mangontrata, no? Ito yung malaking tulong po sa inyo. Meron din po tayong self-paced special webinar, no? Engineering math with calculator techniques. Yan, yung mga gustong mag-aral ng engineering, no? So, kontakin nyo lang po kami, no? Okay. We have a very special offer to everybody listening to us right now. Whether you are in the Zoom, you are in the YouTube, okay, live, okay, YouTube live or FB live. Please listen, no? Nandun pa rin tayo, partner, di ba? Okay. So, kailangan ko ng calculator kasi. All the topic, no, building, wiring, motor control, electrical design, and estimation. And also, we have the topic about how to become an electrotechnical officer. Yung mga gusto pong magbarko. Per topic is 990 pesos. Please listen carefully. No, sa lahat po ng mga uma-attend ngayon. 990 pesos. 990 times 7 topics. There are 7 topics. The worth is 6,930. 6,930. If you are going to avail all the bundle, we call this as bundle course, all the 7 topics, no? We will give you 80% discount. If you will avail up to 5 p.m. tomorrow, that will just become 1,386 pesos. Lahat po ng 7 topic na to, makukuha niyo po with certificate, no? With lecture handouts for only 1,386 pesos. If you're going to avail this online, no, to our website, so it's only 1,386 pesos. If you will avail up to tomorrow, 5 p.m. lang po yan. No? So if I were you, so please visit our website for more details of this promo. No? So we call this as special webinar bundle course. So naka-bundle po yung 7 na yan, 990 ang isa, pero bibigyan namin kayo ng 80% discount. Kung kukunin nyo lahat, it is only 1,386 pesos. So napakalaking discount mga kawerpa at napakaraming matututunan po dito. Okay? So, and we also have, they are inviting you to our free special webinar tomorrow, how does an electrician become an electrical engineer in just 1 year. Ayan po. December 12, Monday, 6 p.m. to 10 p.m. na po yan. So, I am inviting everyone. I hope you will attend to our special webinar. And to all electrical engineering students, those who are studying in the BSEE, included na rin yung mga nag-aaral ng BSEE ETIAP. Okay? For currently enrolled students, yung mga naka-enroll lang po this batch, we have a very special promo to everybody. We have the advanced REE self-paced online review. This is a self-paced. You can study anytime, anywhere, any number of times. Once to sawa ka sa loob ng 2 buwan, ma-access mo yung video namin 24/7 for 2 months. You can review anytime, anywhere. Complete subject with math, ESAS, and E subject with lecture handouts. Original price is 10,000 pesos, but that will just only be 1,990 pesos. Complete subject, around 40 subjects. 1,990 pesos lamang po. And this promo is good only for electrical engineering students. Okay? So, if you are interested, guys, no, so you may avail our very special promo, the e-review. We call this the e-review. Kailangan lamang po namin mga kawerpa ng inyong school ID at ng inyong current registration card na naka-enroll kayo this semester. Yun po ang requirement po namin. No? So, pag wala kayo makapakita niyan, 10,000 pesos po ang price natin. No? So, 10,000. Pero kung kayo po ay estudyante ng electrical engineering, 1,990 lang po. No? Eh, sir, hindi ako EE student, pwede ba ako mag-avail niyan? Pwede. But the price is 10,000 pesos. Okay? This is good only for students. Okay? Pwede rin naman kung hindi ka na estudyante, kaya lang 10,000 yung babayaran mo. Okay? So, we are inviting everyone, no, sa ating pong mga special webinars na yan na ginaganap. No? Okay, our books, no, yung mga REE books po natin, ayan, mga original REE books po ito. Mga gusto nyo pong umorder po sa amin, mga kawerpa. Ayan. Ay mga ibang mga books pa po namin. RNE books. Okay, yan po yung mga binibenta po namin ng mga books. Gusto niyo pong mag-avail. Okay, Master Plumber books. Okay. And this is the Memorandum of Agreement namin ng IIEE na bilang katunayan na tayo ay kapartner ng IIEE, multi awarded ng IIEE. Ayan po ang ating National President, no? 2021 National President. Then the recent President, Engineer Feliciano Padua. Kung meron po kayo ng ID na to, it's only 200 pesos sa IIEE. You can get additional 10% discount sa mga services po ng Powerhouse. This is what we call the IIEE UID. This is a universal ID. Okay? Ayan po, makita nyo, hawak ng ating mga IIEE presidents. 2021 and 2022 president ng IIEE. They are professional electrical engineers. Ayan po, at thank God na tayo po yung napagtiwalaan nila Sir Alvarez, nila Sir Padua. Ayan po, hawak nila yung original REE books po ng Powerhouse. No? So tayo po ay kapartner. Yan po kaming tatlo. Makikita nyo po, ako po yung nasa bandang kaliwa ninyo. Ayan po mga kawerpa. Okay? Naganap po na contract signing mismo sa IIEE head office. Okay, we are inviting all electrical suppliers to promote po electrical products mo. No? So, let us update our practitioner students in the latest trend of electrical technology. This is bridging the gap between the academy and industry. In here, we are going to discuss your specific electrical product. No? I'll be the one to teach or to discuss, to present your product, and also you may send in your representative to discuss your product also, the marketing side. No? But the basic principles, no, I'll be the one to discuss your product, no, so that makita po yan ng aming mga subscribers at yung mga viewers namin. Hindi rin naman biro yung mahigit kalahating milyon, no, na nanood na ng ating mga videos, kahit paano kumakalat na po ang ating mga videos, no, at makikita ang inyong mga produkto at maipopromote niyo pa po yan. Baka may mga nanonood sa ating mga electrical suppliers, no, pwede po kayo mag-email sa powerhouse_eereview@yahoo.com or mag-PM lang po kayo sa aming messenger account sa Marinais Powerhouse. Okay, so with this, we should say, thanks be to God mga kawerpa. Maraming salamat po sa pag-attend ninyo. Sana may natutunan po kayo ngayong araw na ito. Ayan, tanungin nga natin, natutunan ba mga kawerpa? Okay, maraming salamat po sa inyong lahat. Sana may natutunan at marami pa po tayong mga webinar. God willing po, hanggat tayo binibiyayaan ng buhay at kalakasan ng ating Panginoong Diyos na may kapal, ay tuloy-tuloy po ang ating paglilingkod sa inyo lahat. Maraming salamat po and God bless everyone. God bless mga kawerka. Salamat po. Okay. Sana ano na po tayo ha, nakapagpasa na. Mag-leave na po kami, pasensya na po dahil may klase pa po kami. Padala nyo na po, nakaano na sila, no? Nag-fill up na sila ng ating final registration. Mamaya po ay papadala namin yung inyong pong certificate. Salamat po sa inyong mga pag-attend. God bless, mga kawerka.